Hello? Okay, yeah. It should be good now. So basically I was saying that yeah, I started reading the doc yesterday, but wasn't able to finish it. So I'm gonna continue from level 4, which is the REST APIs part. But also yeah, I was saying that gonna get this finished, then gonna go back into the rate limiting project and we'll try a new algorithm out. We'll fix that up, and instead of REST, we're gonna use gRPC and see how that goes. Yeah. Yeah, but thanks again for sending this. Like this, it's been really easy to understand so far. So I don't know if I'm gonna read it out loud or what to do. I might just read it in silence for like the next 20 or so minutes, maybe, or maybe less, because I think the rest part is okay. Yeah, 'cause the sections aren't very long. Yeah. And how are you, man? What have you been up to? Nothing much. We love that. We love that. Okay. Uses protocol buffer, so protobuf. Serialization is protobuf. HTTP2 as transport. Auto-generated stubs. Okay, so we're not using JSON with gRPC. Okay. It's protobuf. HTTP2 transport. Okay, I think that's the same as REST. Um, Auto-generated stubs, so you can call functions like local ones. Okay, so why not? Let's use gRPC. Yeah, I just saw it. REST is on HTTP 1.1. Yeah. I actually wasn't sure because I swear I've seen someone like do REST implementation with HTTP2 or something. Maybe that's what I was thinking about. Yeah, okay. So like REST by default is HTTP 1.1, but some people do use it with HTTP2. Yeah, okay. I'm not going to confuse myself with that now. But it's, it is kind of cool though. So smart data is about the transport. Sends a request, waits, gets a response, sends the next request. Yeah. Or that. I remember reading about some of this in designing data intensive applications, that book. Like the stuff about protobuf and how it's better or more efficient than JSON sometimes, are basically all the time. HTTP2, Service A opens a single connection, fires 50 requests simultaneously. Okay. Yeah, so I feel like for a rate limiter, using gRPC makes more sense. Because if anything, it probably sounds more internal than external. And nobody really needs to be able to read any of the encoded data. Because the only thing you're tracking is how many tokens or how many requests have been made. So I think implementing it into the projects would be a good idea. The proto file, the contracts, and gRPC start with a proto file. So gRPC stored as a proto file. This is a single source. So okay, so the proto file is just kind of laying out the blueprint for everything. So essentially what position everything is going to be in. So you have a user ID, name, email. So 1, 2, 3, and 4. So that when you're actually encoding it, it knows where to look for everything. So it's not going to mess up the encoding because everything's going to be put into, what's it called? What format? It's not binary, but is it hex? What was it? Oh yeah, it is binary bytes. Yeah. No, I don't. I don't think you're dumb as well. I feel like I need this much as well. I think sometimes having everything laid out in a way that makes sense is better. Because I feel like sometimes people just pretend like they understand stuff because they want to, and it's all just like technical buzzwords and stuff. But you feel like you do understand it, but you don't understand it deeply. But when it's laid out like this, you can actually see, oh, okay, that makes sense. Which I like. I wish more people did stuff like this, like wrote out readable documentation or notes and stuff. Because, like, for example, in designing data intensive applications, when they mention stuff about protobuf, like they don't go into this much detail. They literally just say, "Oh, protobuf is better," and they mention all of the binary encoding, but they don't show any like proper examples. And I feel like this is so much better. This is it's a lot easier to understand. Um, okay. So message is a typed data structure. Service is a group of remotely callable functions. RBC get user, returns user. One callable function, the number is 1, 2, field. Text for binary encoding. These must never change once in production. We run the proto-buff compiler proto C on the proto file. Okay. You never write this code manually. This is the autocode gen. If this stub is a client-side proxy object. Oh, God. So sitting between what? So stub is proxy, represents the backend service. Forwards method calls to it with a network. Yeah, so rest is no stubs, no strict contract shared between front end and back end of the OS. If the front end wants to get a user, the developer writes this, yep. You have to fetch the user. If it fails, yeah, so what you in the fetch library are doing. How it happens in gRPC. Both client and server teams share the exact same .proto file. When the client runs, the server C compile on the return system. Okay, that is pretty clean, I won't lie. Zero networking code, no parsing. Okay. Okay, so when you're implementing a service, the proto C generates a base class, you need to extend that. Okay, this is just all in Python, but still. So calling the service. I don't know if this is important enough for me to read or skip, but it just looks like it's a class where we just call everything that's been made previously. So once we actually find out what Go library gRPC uses, then I'll be like, that's gonna be pretty self-explanatory. The full gRPC dry run. Yeah, okay, so we create the request. It's serialized on client side. And then it gets sent over, right? Yeah, transport level request, reps. request is deserialized object. Okay, so yeah, okay, so replace the response object after this part. Okay, and then we get returned like this. Server side objects. Serialization on server side. Okay. I imagine it won't be very much different in Go, but just obviously different syntax because Go is typed and Python is not. I guess Go isn't explicitly typed either, but exactly where serialization happens. Okay, I think this part I can come back to. It's just like all of this isn't really. This is kind of stuff that I'll come back to when I'm actually doing the implementation, I think. Because some I might need, others I might not. So I don't think going into complete detail is gonna be worth it here. Because there is a lot to read. So what I think I'll do is get started on coding. Let's do that. So yeah, I had my VS Code minimized. Where is it? This always opens up. I don't know why. Okay, so what we're gonna do is we want to get started on a new rate limiter algorithm. Yeah. But then again, like the doc is really good. I think. I think once. I think it's partially more because when I'm working, I don't really want to just read everything because I know I'm still gonna be coming back to stuff while I'm implementing. I think it's just like personal preference as well. Um, I don't know if it's gonna be a library. I think I just want to kind of dive deep into rate limiting. I don't know what it's gonna be yet. I just kind of want to understand what's going on with the different algorithms, just as like a low level project, just for fun. But then if it becomes something more than that later on, I welcome the idea. Yeah, I didn't really have many plans for it before I started. Um, but we'll see. We'll see. I think right now what I should do is probably separate them into different ones because right now it's just rate limiter. And if I was gonna split it up, because this one is probably the least efficient of all the algorithms, like I saw on like Wikipedia and stuff, it's token bucket, but we'll see. Um, token. So where I want to start is for this. Let's see that's what we have right now. Our file structure. We have go internal, whatever. Internally, we have only one rate limiter, but we have, and here we have rate limiter dot go, which I don't think is right for like the way that I want to move forward. So what I think I can do is, it's kind of like a way to separate them out. I think I'll make like a general interface. So something like this. And then, because obviously we don't have anything in here yet. So now we'll just token buckets dot go or something. We'll just be moving logic around. So right now we need rate limiter interface rate limiter. Oh yeah, I don't think I see that. Let's type rate limiter interface and start simple. What's the most simple thing? So we want to know every time we what's the only method that we have is allow. So each rate limiter is going to have that. So allow, it's going to return a boolean. Right, so I guess we can't have rate limiter since that's what it's called here. So I guess limiter for now. And then that's fine. So then in here, we're basically going to reuse this, but we want to so we've used that already, but we want to have like an implementation for the token bucket. Thinking about it now, we probably could have just copied all of this. So if I just so this is where we got the problem, because it's saying that rate limiter is being called multiple times. So I guess I could do now, just copy everything and comment it out, right? So here we have this. I'll change this first, and then just thinking about what we call our interface. Okay, this is fun. Okay, so we have that now. I think I can delete this, hopefully. But I'll leave it for now, in case this will be changing as well. So we wanted to make it work no matter what kind of rate limiter we're using. So this shouldn't be here. What would be next? Yeah, so we want to have like a factory method or something that's going to allow us to create different rate limiters regardless of type. That's going to use our interface. It's going to be some sort of like conditional constructor where we'll create a new rate limiter of whatever type whenever we call it. So if we have factory.go right here, and I decided to say, let's get this done first. So oh yeah, since that should be token bucket, I think if we come back here, I can call this rate limiter with no problems. Awesome. Okay, so we're in here. So we've got a new rate limiter, and we want to pick the algorithm. So algo could be type string, and we should get a type limiter back. So type rate limiter, it should be an interface. Awesome. So beyond that, we want to switch depending on the algorithm that's selected. So our first case is if the algorithm, let's say it's token. Is this how we do it? Do we semicolon or? Yeah, okay, semicolon. Don't know why the like format. Or is that just how it looks in Go? They're on the same line. It's weird. Yeah, so if it's a token bucket algorithm, we want to return a new rate limiter. But we don't have the. Oh yeah, I should call this new token bucket. Undefined mu. Pretty sure it is defined. Let's type token bucket. Is that right? Should be. Hopefully. Back to the factory methods on the token bucket. With 5.1, we can tweak that as well. So then, say, should format this correctly. sliding. Okay, we leave time there because we can leave time out because we know sliding window probably needs the time. Right. We don't have a return like defaults. I guess our default can be I think panic's right. Panic builds in, stops any function. Yeah, so I don't know if saying a panic is the same as an error, but yeah, so we could say unknown algorithm. I don't know. Okay, so this for now is done. This doesn't exist yet. We can come back to that. And what we should do is get started on our new algorithm. And then we can kind of put them all together in a way that will work. So we've done token bucket already. The next thing is some sort of sliding window. I think there was like fixed and variable window, right? If I check again, see rate limiting algorithms, because there's a lot of sliding window ones actually. Token bucket algorithm, there is leaky bucket and fixed window, sliding window. Okay. I don't think it, but it doesn't explicitly mention. Okay, fixed window, what's the benefit of that? So fixed window algorithm divides time into equal intervals and limits the number of requests within each window. If the time limit is exceeded, further requests are blocked until the next window begins. Okay. That shouldn't be hard at all. So essentially we're given a set window, let's say of 5 minutes, and then within those 5 minutes, you can't make any requests if you use all the requests within those 5 minutes until the next block of 5 minutes, okay? I assume. Yeah, sounds right. So we'll say fixed window. Package rate limiter. Definitely need time here. And since we want new texts as well, like the other one, basically going to be similar structure to token bucket, except we're not using tokens, of course, we're using time. So sync and time because we need thread safety, we need time. As far as logging, I don't think we need that until we get to the handlers. Show type fixed window. It's going to be a struct. Within the struct, we need mu, which is going to be type sync. We need a request count. To count the number of requests that have been made within the window, I guess. Because it's going to be like, yeah, use ints here because unlike tokens, we don't need to have partial token amounts. Because before we were able to say back 0.5 tokens every second, but we can't really use half a count of a request. And since we can't, get a partial request, we need a whole number. So, and it's what we're gonna have to use. Then we also need a limit, which will be an int as well. We need a window, so it's gonna be time dot duration, and in order to actually know whether, yeah, so we need a start time. I wonder if I use, okay, these were capital. Yeah, I think I should make these capital too. Counts, limits, so I can actually access them. Start, and start will be time dot time. Awesome. Okay, so beyond this, we need our constructor. Hood up, hood up. New so limit, and then the window will be and we return window. And here we return at, oh no, where is it? Ampersand fix window. What actually needs to be specified or declared? So limit will be limit window can be window. Okay, the other way around. Window. Start time. This window start maybe. Both. Window start can be equal to oh yeah, the moment that it's called, right? So timeout now. Just need to remember my functions. Yeah, so then outside of this, we just have our allow function, right? And since we're already using our mutex, we could just do that. That's the first thing. So func allow. Actually, we need our allow window. Return type boolean. So rate limiter dots defer. Oh no, rl.mu dot lock, and then defer rl.mu. So here we say now get our initial time. We'll say recognize time dot. Let's not sub do it again. Yeah, that's up. So subtracts, right? Returns time minus u. Right, so we'll say if now dot sub rl dot window starts is greater than window. Then we can say we start a new window. So f window now say rl.counts can now be 0 because we've made no requests in this. Say if rl.count is less than rl.limits, and keep making requests so it can be allowed. So rl.counts plus and return true, otherwise we return false, because if we can't increase it, we return false, right? And that should be it for now, unless we need to test anything else. I think sliding window is probably the hardest, and that's probably not even that hard. So now that we've made that, I think we should go back to the factory and say, yeah, so we can add fixed here and just leave that comment for sliding window, because I thought that was what we were going to do next, but fixed is probably the better option that we did. In return, this window. Say our limited number of requests we can make is 5, and time duration, we can say time dot second data function? No, unless we 10 seconds. 5 requests every 10 seconds, maybe. And then as far as handler, I think handler I can get rid of completely, and we'll replace that with something else. No, wait, no, not handler. Damn it. Okay, yeah, handler's back. It's the rate limiter manager I can get rid of. Because I don't think it works the way that I think it should. Instead, what we should do is an internal, we can introduce a package like store or app or something. Store is better because we're not only going to be storing the maps, maybe. And then we do like store.go, I don't know, or manager.go or something. Or I think for now, like overthinking it is probably what we want to avoid. So we'll say package store. We're going to import whatever we had in the last one. So say we import to sync, and because we need, we need the rate limiter module, because we're no longer in the same package. So .com slash API rate limiter /, internal / rate limiter. Awesome. Okay, so type store and we need our map. We also need a text. We need a map. Limiters. Limiters or something. We have limiters already, and I don't want to have to go around changing it everywhere. I think we use limiters here. Okay, where do we call our map? I remember having to do it in main. Unless no, I think we kind of stopped using that completely at some point. I think 2 days ago I got rid of it because we were just creating new ones just to test when we were doing the bash commands. Because nothing's really persisted at local time for now. But we can, yeah, so I guess I can give this any name. So rate limiters is fine. Map of string, which is our user, will return rate limiter dot rate limiter. And then we need a constructor for this too. A constructor for this too. New store. Return store. And just make, right? Yeah, so rate limiters will be make map string rate limiter dot rate limiter. And that should be it. So then beyond that, what do we need? We need our get rate limiter function that we had. This, but it should be able to work no matter what the type the rate limiter is. Unless okay. So we say flunk new. Okay. Get rate limiter string ready string. And it's gonna return rate limiter. Yeah, awesome. Let's see. Check accept real quick. get rate limiter, dot rate limiter. Essentially just getting from the map. But the first thing we do is we need the store. So we need to access the stores. Alright, so S. We need to access the stores mutex. S over start. So say the rate limiter exists is equal to s dot rate limiters. So if it doesn't exist, RL is equal to O. I'm trying to think which is the safest rate limiter to fall back to, because we can't really like randomize it because that makes no sense, but also we can't give the user a choice without putting the algorithm as a parameter here. I guess fixed window makes the most sense because it gives the user the least control. So if we just had a random like what did we use in the factory? So 5 and then 10 seconds, yeah. Which is kind of crazy. Now that I think about it, it should be like I'll do 5 every 2 minutes. So 5 minutes times 2. Okay. So your rate limiter is going to be equal to start fixed window 5. Sorry, minutes minutes times 2, and we just returned our rate limiter at the end, but we want to actually say that s dot rate limiters user ID is equal to RL, and we'll return so the handler shouldn't have much change now because we don't have a default in these. Store so we just need to change where that's coming from. Wait, was there handler should be GitHub user ID string store. Is it because they're connected or what? I have an idea. Let's separate that again. Internal. So let's go here and say dir internal slash handler touch internal slash handler dash. Go. And we'll just LGBT plus. Okay, so here, what's the problem? Could not import internal rate limiter, missing metadata for import of C. Missing. Check go mod, maybe. I don't know. Is this wrong? API rate limiter. Or maybe I have a spelling mistake, hopefully. I'd love an explanation. I think it's wrong, but I can't see how it's wrong. It's weird. Okay, let's see. Can I, let me see, because this works, right? No way, so. We don't have rate limit handler, which is fine. But we're able to access rate limiter, which is okay. So what I should do is just copy this line, go back to where it's failing, which is here, and paste that there. See, but it's able to find it just fine. I'm so confused. Why is the import broken? Oh, okay. It says it here. The internal directory go restricts access to package only code within the same module. Oh, okay. That makes sense. Makes sense. Okay. So I think rate limiter should be the only thing internal. Or maybe store should be outside of this, right? Yeah, okay. And then once we go to our handler, just call store. Why is this not working? Undefined store.get rate limiter. Okay, so if handler goes outside too, what happens? Okay, it still doesn't work. Let's close that. Undefined store.get rate limiter. I'm gonna get to the bottom of this. Okay. Really can't figure this out right now. So I'm just gonna all I say is let me look at the my project structure. So so can we look at find store that's how we'll resolve that. Um, Anything else? I don't think there's really much need to do anything else. Look appropriate, the undefined, or is a method on store, not a package that will function. So store get rid of it won't work. You need a store instance to call it on. You need to either pass store into the handler or add a package level singleton function that maps it. So method on store. Just not package level. What does that mean? We're literally in package store right now. Okay, so in Go, there are two kinds of functions. Package level function belongs to the package call directly. Okay, method belongs to a type, needs an instance. Okay, yeah, I got that. So I need to make an instance of the store. Okay, so we can keep that there. Then when we go back here, we can obviously get rid of this now. We're gonna go to here. To our handler. What's that again? I just completely forgot. Okay, so it's gonna be a bit weird. So if I just did that, went funk. Returning a handle function, so we're backing a function and a function essentially, and add this here. And we're returning this. Okay, amazing. Okay, not much testing has gone into anything yet. That's okay. Also, we can get rid of this. Then here we should add wait, just time. Say it doesn't exist or what? Okay, it's imported but not used. Why? Handler. some stuff that I just don't even look into that I definitely should look into that makes me feel kind of dumb sometimes, which is that was one of those things. There's obviously makes no sense why I had that. It's right later. I guess since I copy pasted, I forgot about it. So okay, so now we can't use that. Oh yeah, and also it's because this itself isn't the right function. We need the actual results to be right. So say handler equal to our so h equal to rate limit handler, right? Let me pass h in here. Was there an input? Oh yeah, so we need store as well. Where's the store? Awesome. Okay, figured it out. I think we're error free now. So now we can say I guess I could call it a refactor as well. Say switched just having refactor. I don't know what it's introduced interface store, etc. No, I think we're good. Yeah, I think we're actually good. Beyond this, what would be next? Oh yeah, the gRPC stuff. Because this isn't our handler, right? So So let's go here. So we've done our first two objectives, which are reading about gRPC, implementing a new rate limiting algorithm, what should be next. Yeah, just implementing gRPC. But I'll be back in like 5 seconds. I just need to go to the other side of the room for something. I'll be back. Okay, let's get active gRPC. Okay, so the first thing we'd have to do is create our .proto file for the API. I think putting that in the handler is okay. I'm not sure if it goes in the root or in the handler, but we just start off in the handler and fix it if it doesn't work. So, proto, and it'll look something. We'll just use the one from before as the guide. So, is that right? Or is it like this? Okay, we'll do it like this. Let's see how it looks. Because I don't think they have syntax highlighting either, so that's fine. So we make a service called and then RPC check. Rate limit request. Terms, rates, response. Message. So now we just define the data structure. Rate limit request is going to be the only thing we request when we rate limit is the user ID, so we know how many requests or they have made, or how many tokens, or whatever, depending on how it's structured. And that is not how you spell message. String user ID 1, and then response. Response. Is it allowed? Bool out. Bool 1. String. Message. So that's all that should be there. I don't think I have Proto-C installed, so I don't think I'll be able to just be like Proto-C. Let me see. Yeah, I don't have Proto-C. I'll have to install that one. Oh boy. Okay, use open get. So shell. Gonna have to move you over to. Okay, never mind. It's fine. Get install. And then I'll have to restart the terminal once it's done. Yeah. So oh, it's done already. Okay, beautiful. So we're gonna come back and say Proto-C. See, I'm so confused as to why that keeps opening. I don't even use. I've never programmed in C#, so the fact that this is even still opening up is very annoying. C# workspace requirements. Let me just uninstall that. Uninstall this, and hopefully that stops everything. Because I'm so confused. Every time I open this project specifically, it just opens that up every single time. Okay, so Proto-C. Go out equals dots. Actually, let me ask a better question. Let's make Awesome. And to generate our Go code. Also, yeah, it's looking for dngi. I've never installed that, so I'm confused about that too. Just find out. Okay, so proto C. Go to RPC out close. Messed up there. I can't even go back up. Okay, it's a shame. Cancel that. I'll just copy this command. No, I can't, because I want people to. Sorry, I'll forget. Proto C. Go. Go to RPC out close dot proto /remainder dot proto. Okay, so on line 4.1, it's expecting a. Is this after the word syntax, maybe? Yeah, I'm missing a semicolon. Okay, so this should work now. Protogen go is not recognized as an internal external command. Plugin failed. Okay, let's see. Clear that. I need this to actually be able to do it. I assume that's done now. So hopefully this works now. All right. Look at that folder. search entity, text the variables, path edits, open. Literacy, Gen version. Look at this on the other screen. Like SPCD. So I just need to add that to my environment. Okay. So does it add it to go path or path? Okay, so it's a path. Edit. New. Browse. D. Okay. Okay, so now I close this, open it again, and we should be in business. So it's C go or Gen Go or Go Gen, I can't remember. Yeah, Gen Go. Awesome. So we should be in all the way in business now. All of these onto start to second. So Proto C go out, full stop, next line, go g.pc out, full stop, go slash rates, enter, okay. New error means progress. So it says I should do this. Let's say option package. Slash API rate limiter. Okay, so now try again. So why does that work? Not. It literally just works and stopped working now. I don't know. So photo C gen goes. Okay. So for some reason this is failing. Need another package now. Okay. I just got a. Oh, okay. Sure. I'm missing another package. That's why it's not working. Okay. Just get this then, and then add that to my path. Oh wait, no, it's already in the right path, right? So I should be able to just check the versions from there. Awesome. Okay, so now that it works, we should be able to just do that command, hopefully. Yeah, okay. Nice. We have our... Wait, it didn't do it right. Okay, so source relative. Awesome. Okay, now we have everything we need. Okay. Just a lot of errors here. That should fix everything, hopefully. Anyway, while we're waiting for that, what we can do is oh, good to go. So then in handler, I guess it doesn't really matter what the file is called. Just call it. Then I can call this one grpc. Cool. And then we'll just same package. Import context. Yeah, and then we github.com slash and slash store. Type grpc rate loader server struct. So we have to handle the server from the file that was created, the .go file that was created, pb dot. pe.on implemented rate limiter server, because that's in here, right? Yeah, that's that. That's a start. Store, just type store. UGRPC server. Type S store. X server. Only field we need is store, which is a okay, so what else we missing? This like the allow function itself is fine, right? Because we're not getting a specific rate limiter. We're just checking the rate limiter itself. We're getting what type it is. It's going to go through the interface, find the right one, and then call that type of rate limiter's allow function. And there's no HTTP there. Fine. So here we just need a function to check. So G is going to be type G RPC rate limiter server. Check. Sorry, context. So context, about context. Request is going to be type dot requests, and we're expecting a response back. One can only help. Okay. How is context undefined? Oh, disappeared. We reached the 2-hour mark. Let's go. Let's go, guys. It's right D. Quest is right. It should have been. Wait, that's not good. So we have our user ID. We've processed that. That's all we need to actually make a request. Then the rate limiter itself is going to be equal to get, or we call rate limiter, or our server is going to have its own store. So g.store.get rate limiter ID, and we have RL now, so we have a rate limiter. So now we want to say if not rl.allow, then what? Return eb.rate response. Inside the response, what do we say? It's going to be false and then a message, right? So loud false and then message if it exceeded. And what else? It's gonna, because we're store, what is it? I can't see. Okay, an error. We don't have an error, so just be nil at the end of that. And then outside of that, if it does succeed, we want to return rate response loud being true and request allowed or something. Request and also no error. Just very basic. Do Go projects have lib files? Oops. Where? Yeah, so maybe if I had like wait, can I, it doesn't give me the option to collapse a folder, which is kind of stupid. Okay, so in internal, I want new folder, server. See, or maybe something like that. And then say package server. I want to be able to start that server. So let's have some logs once in a while. Log. If we have a log, we don't need FMT. Next, we want google.golang.org. See, it's installed already. PB, which was proto. So this is local. kingdom API limiter slash we have handler and store. So take slash handler. We'll just use store here. Okay, so beyond that, just try my best not to save so we can actually use everything. So say func start grpc server, take s type store dot store, not returning anything we just started, it's void until it stops. So say listener error is equal to net.listen. Yeah, just to be more verbose. So listener is net.listen. We're gonna listen on TCP on ports 50051. Okay. So if error is not equal to nil, we are just gonna cancel because we can't return anything, but we can log. So log.fatal, so you know it crashed. Fatal F, certain formats. Failed listen. And we get a value here and this one there. Missing, right, like that. Cool. Outside of that, so say grpc be equal to grpc, which is dot over here, grpc dot server. So pb dot register rate limit server, register rate limit server, grpc server, and pb dot, no wait, we need what? The server rate limit server, so handler dot new gprc server on what? A new store bs. Awesome. Cool. And then after this, we just F. We don't need a format. Server running 5051. Sure. So then if error grpc server dot serve listener and our error is not equal to nil. So if we have an error and that error is this and it's not nil, we want to return this log F. Beautiful. Okay. And because we don't use this, we want to come to main, and then within here, we're just going to handle all of our other stuff. So grpc stuff. So say go, put this in a go routine. So start gRPC server on store. We don't have that, so we're gonna go to or no, slash internal. And then this should be I should have that there, and then this. Yes. So now if I run it, hopefully we run into some errors. So I'm joking. Hopefully we don't run into any errors. So I can test it. Okay, server's running. And let's just want to test this on gRPC. It's meant to be like a sample curl command, but I don't have grp curl. So I don't want to have to download gRPC curl or grp curl or whatever it is. It'll just let me input my .proto file according to the internet. So let's see. How do I specify that I'm using oh yeah, HTTP request, AI request, MCP request, gRPC request. There we go. Import a protofile. And then after I've imported that, we'll just figure it out together. So my projects, this API, rate limiter, proto.proto. Okay. Check. Is this gonna work just straight away? Or... Wait, we should be getting feedback here. Yeah, okay. That crashed the server straight away. Let me just make sure. Okay, yeah, it was the call from invalid memory address or nil pointer dereference. Okay, so invalid what? From what method got called? Check. What's the lowest handle stream? So this is all from the gRPC stuff. So I must have messed up somewhere. See, this is what I mean. From what I read, at least I was thinking that, yeah, it's gonna be hard to like debug, harder than HTTP at least. Source. Explain. Okay. Number one teacher. Variable shadowing if not exists, RL. Declares a new variable, RL, that shadows the outer RL. The new rate limiter is stored in the map, but the RL, which is what gets returned, remains its zero value nil for an interface. So get rate limiter returns nil for any first time user. Panics. Oh, okay. Shit, yeah, okay. Yeah, it's already declared here, so saying, yeah, I'm creating it. Okay, yeah. Awesome. I thought it was something else that was causing it, but yeah, it makes sense that when we're trying to get rate limiter. Did the error even mention get rate limiter? I don't think so. But it does make sense considering the fact that we're trying to create a brand new request. Okay, so we'll start the server again and see if it works cleanly, because I don't think with having only one method in the entire thing, or one function in the entire thing, there's not much room for mistakes. Yeah, so we got it past that time. See, we got a okay. So it should fail if you do it like 5 more times, right? Or it depends, because what do we fall back on? In our store, we make a new fix window. Our limit is 5. And our window is 2 minutes. Yeah, so it shouldn't allow us to do all of these requests. Oh yeah, okay. There it is. I should have been looking at this. This is what I should have been watching. Rate limit exceeded. That's fine. Okay, so I'll start it again, and then we'll be able to actually watch when it changes. Okay, so it should be allowed the first time. Okay, so first check, true. 2 is true, so we got 3 more. Allowed, 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 and the next one should be false. Awesome, okay. gRPC implemented, let's go. gRPC server, protobuf. Rated. What else is there really? Yeah, I guess that's it. Yeah. All right. Zweichenzug, thank you. Or Zvishinzug, thank you for the shout with the and all the help with the gRPC stuff. If you're still there, and if you see this later, I'll say thank you. Next time you're in your stream, or next time you're here on the stream, I'll give you a shout out again and say thank you. Yeah, that's it for today. I think tomorrow I should start working on sliding window, and maybe some persistence as well, because having it reset every single time is good for testing, but I also want to test like state management and stuff. So we might use like a database or something. Maybe like not MySQL, maybe what's it called? SQLite. Try that. Yeah, so until then, I will see you guys. Stay blessed.